Okay, so line's best fit. When you do statistical analysis, your data is not always going to be perfectly on the line. You need to know how to deal with that. Okay. So if I'm going to give you some data in a table. Just a generic math example of how to calculate a line of best fit. I've given you all positives, and most of the time we're going to be hanging out in quadrant 1. So we'll just make everything up there. You guys can put those points down on paper, right? Yeah. Let's add a couple more points here. Okay. Good. So you've got a plot there, right? Obviously, they don't follow a line. So how are we going to? Our goal here is to show a general trend. Do they have a general trend in this direction? Kind of follow a line, yeah? So we want an approximate linear model. Okay, that's what this is. A line of best fit is an approximate linear model. And it's not going to be perfect, it's just going to be useful. So, you think that shows kind of the general trend? We've got 3 that are pretty much on it, right? Yeah. 2 below, 1 above, kind of pretty close. Yeah, good enough. All right, so take, and I'm going to use my line tool. And I'm always, okay, put it between and that'll help you a ton if you put it on 2 points, okay? Because now you got 2 points to calculate what? Slope. Oh, that is not. Now we can write an equation. Don't fall asleep.
Okay.
How do I write an equation for that line? Okay. Step one is the slope. What are these points? And 5, 7. Okay. Calculate the slope. Let's see. So now, what's my equation? What is an equation? Oops, that's not what I wanted. You guys ever have that problem? Your hand acts before your brain catches up. Okay, that's one option. Is there another option?
There's that one stack.
There's another option. You could also calculate the y-intercept and write slope-intercept form. Let me show you that one. It's probably what you worked with. Let's do
I
that.
thought about trying that one, but I didn't get my slope exactly.
Okay. Slope is 3/5. So we have our goal is to calculate b, right? So I'm going to plug in a point. So I'm going to use 0, 4 because it's got a 0 in it. The zeros make my life easy. So 4 is the y. 0 is the x. And wouldn't you know that my b is that this here is 0, right? So 4 is b. So y equals 3/5 x plus 4. So those are three different equations. You could also pull the y-intercept from here. The graph.
Oh,
0, 4. Yeah, you can just write that one on this example. Yeah, notice the match between this graph, the numerical y-intercept, and the graphical y-intercept, and the tabular table. It's all right there. You don't have to be perfect on these. The perfect one, yeah, I'm not even going to show you. Because it's a pain in the butt. Here's some vocab for you. This graph exhibits a positive linear relationship.
okay.
Positive slope, right? What would a negative linear relationship look like? Down to the right. So negative would be like this. Okay. Keep that in mind. And you guys probably heard about independent and dependent variables. Which one's which? The X variable would be, right. And then the Y is the keep those vocab words in mind, they'll show up. I know you've learned them, but just keep them in mind. So again, this is more of the same. We're getting to the point where we can apply it more to real problems. Okay. Do you have any questions? Can you handle some work here? I hope so. By the time we're done with linear functions, you're going to be sick of them, but you're going to be able to do them. Let me get your work to you, and you can get some done.